Bismillah. see it has the 1s2 configuration as well. In its valence shell, hydrogen atom also has 2 electrons just like the helium atoms, and we say that helium nuclei has 2 protons and 2 electrons, and it is stable. So the hydrogen atoms, when they combine and they share their outermost electrons, what happens? It acquires the noble gas or this helium gas configuration, which is the nearest. And all those elements in the periodic table in the right hand corner of the periodic table, if you look at the lithium and beryllium and hydrogen, which is on the right hand side above the alkali metals, all these obey, like hydrogen, as you can see here, lithium atom, we will show it as well. The helium atom also acquire the noble gas configuration. Why they obey Duplet rule to acquire noble gas configuration? They obey Duplet rule and acquire noble gas configuration in order to get stability. So atoms which obey Duplet rule and they are in need to complete its outermost shell with only 2 electrons, as you can see in the case of hydrogen, they do this very thing, or they do share electrons, outermost electrons, in order to get stability, so that they become stable or peaceful, and they are not reactive anymore, so they become peaceful. And this is the hydrogen molecule. Hydrogen molecule configuration is similar to the configuration of which noble gas? Helium. Helium configuration similar to the hydrogen gas configuration. So both of these are stable element, or we can see elements, the tendency of elements to acquire 2 electrons configuration, the tendency of electrons to the tendency of atoms of elements to acquire 2 electron configuration in their valence shells during bond formation. When they are forming the bond, they do form bonds in order to get stability or noble gas configuration. All those elements which obey Duplet rule will have the tendency to complete its outermost valence electron with only outermost shell with only 2 electrons. Helium has complete duplet, which means that helium obeys Duplet rule. Similar to this, we can also say that elements closer to helium obey Duplet rule. So if you examine the periodic table and you look at them, you will observe that all those elements like hydrogen, lithium and beryllium obey Duplet rule when they form bonds with other elements or themselves. They attain the electronic configuration of nearest noble gases. In case of Duplet rule, it is helium gas. Helium is the nearest noble gas and becomes stable. Lithium atom, if you examine, has 4 form bonds with hydrogen atoms to form lithium hydride. And lithium loses 1 electron to keep 1 electron in its valence shell, and in this way it obeys Duplet rule. So if you look at the lithium hydride now, LiH, its symbol. This is the LiH, lithium hydride. This is the compound which is formed by the combination of the outermost electrons of lithium and hydrogen. As you can see here, the hydrogen has only one electron, and if you look at the atomic number of the lithium, so if we draw lithium over here, it will be somehow like this. Lithium has 3 electrons, atomic number 3. Lithium has atomic number 3 and atomic mass. So it is the lithium, protons, 4 protons, 3 neutrons. It's a lithium atom. Nucleus, the nucleus, it is its outermost shell. The lithium atom outermost shell has these 2 electrons, as the maximum electron in the K shell has 2 electrons, and as you can see, lithium has 3 electrons. So its outermost or M shell, K, after K is the L shell. This is the L shell of lithium atom, and it is the outermost electron, outermost valence shell. So here is another electron. So what will happen when hydrogen will come in contact? In this case, when hydrogen will come in contact to make bond with it, hydrogen has 1 proton and 1 atomic, 1 neutron. It has 1 proton and 1 neutron. So it has atomic number 1, atomic mass 1. It has only valence shell, and it has only 1 electron here. So in this case, in lithium hydride case, this lithium will donate this 1 electron to the hydrogen atom, or share this electron with this, in order to get electronic configuration of noble gas helium. And similarly with the hydrogen atom, as you have seen it in the above example of the hydrogen molecule, the hydrogen atom will share this very electron with the lithium atom, and this will become like this, that this will be the helium lithium nuclei, which is K shell, which is already completed with 2 electrons, but it wants to complete its L shell with 2 electron, as well as it is its outermost electron, outermost shell. So what will happen? This electron will travel to the hydrogen atom. This is the hydrogen nucleus. Here is the proton, its outermost electron. So this very electron which hydrogen has, and this very electron which lithium has, with this very electron lithium has its noble gas configuration, and with this very electron of the lithium atom, the hydrogen atom has also completed its duplet. So both these atoms has completed the duplet rule, which indicates that lithium hydride is a stable compound. Why it is stable compound? Because both of its atom has attained or acquired the noble gas, the nearest noble gas configuration, which is the helium atom configuration, has 2 or duplet electrons in its outermost electronic shell or valence shell. Both hydrogen also has 2 electrons, and lithium also has 2 electrons. And what they did when they bonded, they share their outermost electron. It has also in need of 1 electron, and lithium has also in need of 1 electron. So there is a possibility If the lithium donate this electron to the hydrogen atom, even then lithium will be stable because its outermost shell will be this inner shell, and it is already in it will be in a stable state. But in case of hydrogen, hydrogen will have to share its electron either or accept another electron from the lithium, and this way both of them get the duplet rule configuration or helium gas configuration. This is all about the duplet rule configuration. We will recap it. So duplet rule is that rule in which atoms of elements has the tendency to complete its valence shell with only two electron, or K shell with only two electron. Its examples are hydrogen, lithium, and beryllium. They are near to noble gases, helium, and they acquire the duplet rule to become stable. Beryllium has bond with two hydrogen atoms to form beryllium hydride. What beryllium does? Beryllium donate its electron with hydrogen atoms. Beryllium loses two valence shell electrons and obeys duplet rule. Similarly, each hydrogen atom gains one electron to keep electrons in its valence shell and obeys duplet rule. Lithium hydride has this very electronic configuration. This is it. If we make it's a little easier, lithium hydride, like lithium hydride, lithium has first shell 2 electron, and the L shell has 1 electron. It donates one electron to the hydrogen. Hydrogen becomes stable, the lithium becomes stable. So if we add another lithium atom and another hydrogen atom, it will become more stable, because in that case hydrogen or beryllium hydride is much more stable in that case. Hope this makes sense. In next video we will discuss octet rule, inshallah. Allah Hafiz, take care.